I'm Wallek, I'm Wallek, and from America. I speak some Polish, very elementary. So, for the topic of this discussion, will be in English. I'm from Aqua Security. Not sure. Maybe a show of hands if you've heard of Aqua or Liz Rice, if that sounds familiar. Okay, so this is new. That's good. That's good. So, just to get us started a little bit, I want to just get an understanding of how many of you guys are running containers in production today. Just show of hands. All right, looks similar. So recent studies, it's about 60% of organizations today have started to adopt containers or intend to deploy containers. The big push is coming from application developers with the need to move quicker with the agility. And on the other hand, there are some skill gaps and some challenges still being solved in the industry as far as security and infrastructure decisions that still need to be worked out. But the reason why we all really like containers, it's the same, and that's because we like to keep things very simple. We like to scale our applications very quickly, and we need to be able to deploy and run them on any infrastructure, on your bare metal data center, your VM cloud, VMs in the cloud, and maybe you're moving to some type of hostless environment like an ACI or a Fargate where you want to start to engage with serverless technologies. And for those reasons, containers as well as cloud native workloads have really become the standard today. And the last 3 or 4 years, organizations that I work with, I've only been with Aqua for a year, but they've started to now deliver their mission critical applications in containers. And a lot of that reason is it comes down to the packaging. What's in the image? It's the base OS, the middleware components that are packaged and required to run your application, and then you deploy your code on top of that image, and everything inside is sealed, and everything that application ever needed is sealed inside the image. And there's no fuss now around or questions around what types of infrastructure or prerequisites would be required to make errors that would essentially slow down the deployment of these applications. And this lack of delay or need to roll out these applications very quickly is what's caused organizations to lean towards automation. So containers are just so closely related to DevOps. I don't know how many DevOps people are here in the room, but if anyone has a good definition that they'd like to share, what their definition is for DevOps, I'll give you one of Liz Rice's new books. Any takers?
Okay, so DevOps is sharing both operations and development work in the same person. You have a team that can do anything from writing code to deploying and supervising it on servers.
I like that one. Congrats, you'll get a book. I'm just going to share what Svi, our solution architect at Aqua, says. DevOps is essentially the art of doing infrastructure in an automated way and writing programs to manage other programs. And the container is no different once we have the image in place and it's delivered by the CI tools. The container images are then shipped into a registry where they remain very dormant. And usually the container engine is there running either on-premise or in a cloud environment that is operating to open the archives and deploy this image into the compute environment where it's supposed to run. We have procedure. If you want to dive a little deeper, what we're doing is we have procedures that are essentially governing the creation of the containers and also the running of the containers. And once the Docker file one of those is in a Docker file, a way to produce a procedure that would create an image. This would contain what is in the image packaging components that we previously discussed, and you can change the user context to add ports that need to be that exposed to run that application, and the code that is going to be needed once it's ready to run and be instantiated. And all of this is going to create an image. And for example, if we're talking about a JBoss image, what's used to create the that would be used to create an application server that you would basically start to run your user code on, but it would remain dormant and doesn't produce a running container. In order to run the running container, you would need to put it up into a runtime environment, and I'm sure most of you, since we're here and this is a Kubernetes meetup, would throw that into a Kubernetes environment. And let's just make one thing clear. We all love containers, and we all think that containers are great. They're great for DevOps, or for developers, for operations, and for security too. And those reasons are around that everything inside those images is pre-configured. We have automated procedures to orchestrate and move those applications very quickly. And the footprint on the VM is very low, and the availability to keep your applications is also very, very elastic, and it's predictable, and the overhead is minimal. And by no means are containers not secure, but they simply do not align with everything that we're talking about here. Security is much more hands-on. They like to have control in a stable environment, something that is less hectic. So, they are still applications at the end of the day. And to the outside world, it's no different if you're running that application on a physical server, or a VM in the cloud, or a bunch of containers running in an ACI or a Fargate. The application components are still susceptible to weaknesses in design, coding, and execution. So you still have your same DDoS attacks and a fork bomb. You still have escalation of privileges to try to exfiltrate credentials from your containers, try to exfiltrate customer data, to move laterally inside of your containerized environment, or potentially try to inject malicious code. And from a security angle, the development is making essentially infrastructure and stack decisions, in their opinion, and the code is moving so quickly they don't have the time to really audit and analyze the risk that they traditionally had on a smaller environment where they were managing maybe 10 hosts, and now you're managing 1,000 hosts that are there for 2 minutes and gone the next. And if you're talking about a function as a service, you're probably not even paying for the audit logs. So now, what is a security professional? How are they going to audit, and what do they do with this? But at the end of the day, we need to acknowledge that the weaknesses in application design, coding, and execution, it's magnified significantly when you start to move to a cloud-native environment where you are running these hosts over and over and over again, and it's all really, it comes down to the images and making decisions early on in the process. The selection of your operating systems, the sources of your images, where they're coming from, public, private registries, packages, the additional packages that might not really be required to run those applications. You want to think about what types of ports are exposed, how you're configuring your image user context, and have you embedded any secrets inside of your containers? Because are you running as root and in your user context configuration of your containers. You want to essentially write code in ways that you have security mindset, and you're not storing your keys. You're using thin operating systems like an Alpine image as your base images. You want to use just the least, most efficient operating system possible. And it's not possible, but if you can use as little of vulnerabilities from open source software, it's not perfect, but you can try to get better. Now I'm going to jump into your Kubernetes configurations. There's a number of different things that you need to start to think about when it comes to Kubernetes and how you configure your systems. One of the things is the etcd database. Who has access to the etcd? Is that a least privilege approach that you've taken? Essentially, anyone who can write effectively on your etcd database effectively can control your cluster, and just reading components in a read authentication method is enough information for an attacker to potentially understand what he would want to exploit in other areas of your deployment. You should really only configure that to an authenticated user to have access. Same goes for the API server. Essentially, full permission user access is like the equivalent of root access on every machine. If you can manage to get into one kubelet, chances are you can make your way into the others. And therefore, that's not perfect. I understand there's different installers out there that address some of these issues from the earlier days of Kubernetes, but things have gotten much better since 1.8, and but still keeping that in mind is always useful. So we talked about restricting access to the etcd, the API, the dashboard. Start using rule-based access controls, at least on a cluster-wide configuration level. You might want to also start to adopt some different types of to secure your network segmentation, different types of service meshes that aren't out of the box available in Kubernetes. And then also you want to think about how you're managing your secrets, especially if you're using it natively out of the Kubernetes environment, storing them inside the etcd database. Please encrypt it if you do. Otherwise, use Vault or something else to store your secrets. So how does this all look in the pipeline? Well, in the pipeline, you really want to start to think about shifting left. I don't know if anyone's heard that term, but just bringing the security closer to the development phase, because one, there's the skills gap. There's really only one security professional for each developer, and they don't live in the same world. They don't ship and deploy every single day. So if you make it easy to train your developers, make it easy to consume, and make them think beyond just vulnerabilities in the packages that they're using. Think about, teach them how to configure and use the right configurations in the way that they're treating their images like it's essentially a server, because that's what they are. They get spun up hundreds of times. Still continue to automate, because you don't want to treat essentially risk that you're bringing into the pipeline into your registries the same way you would a bug. I mean, would you put a bug or a flaw in your functionality and software and let it run over and over again? It's the same thing with risk and security flaws. You want to start to address that earlier and earlier in the process. Runtime protection. This is something that at Aqua we do on the enterprise level, but it's essentially, you want to think about least privileges and making sure that the the application can really only do what it was originally intended to do in its state. And if you have a microservice architecture, it's a fantastic model. It's actually more secure. With runtime protection at Aqua, we do an analysis of the different system calls, the files, container accesses, we profile it, and essentially we sit on the Docker socket as a sidecar container and are able to block any malicious commands that weren't originally intended. For the free stuff, this is where we give back to the community as some of the thought leaders. We have a number of different tools, the Microscanner, KubeBench, and KubeHunter. The Microscanner it's a really easy tool for developers to start to scan for vulnerabilities in their images. You need to essentially embed the code in your Docker file. It runs a scan in your build, and you can also plug it into your Jenkins. It'll block all high vulnerability builds that are known out there and have a fix associated with it. Just as a sample, this is kind of what the Aqua Microscanner gives you as an output. This is a medium vulnerability that probably wouldn't end up blocked because there isn't really a known fix for it. But we give you, the impact statement, the NVD score, the vendor severity score, and the maintainer of the package. And most importantly, we also give you the fix that should be used as a developer, because it's helpful and it falls in line with shift left. The next one is KubeBench. This is our automated CIS benchmarking tool. So how many of you are familiar with the CIS benchmarks for Kubernetes? No? It's 250 pages. So it's unless you love CIS benchmark tests, it's essentially CIS. So it's the Center for Internet Security Best Practices. Currently, the 1.3 version supports up to Kubernetes version 1.11, and it's about 200 different recommendations of how you should configure your Kubernetes clusters. And the KubeBench runs, it's an automatic test that is launched as a container on each node that you would like to understand how it is configured, and it'll give you a pass-fail analysis, and it's not perfect. We recently had a conversation with someone who was running on GKE, and GKE, because it is a managed version of Kubernetes, some of the networking failures don't really apply because Google had their own version of networking in the background. And you can modify the YAML files yourself to essentially tune it to your infrastructure and start to deploy it on different nodes. The last one is KubeHunter. This is a pen testing tool. So companies often hire different pen testers to attempt to try to hack into your systems and tell you what they found and how to remediate it. And KubeHunter is specifically for Kubernetes. If someone attempted to break into your cluster, it's a Python script that actively hits on different subnets to scan ports and see how they're configured, and gives you some recommendations as to which configurations would be something that would need to be remediated. And you can find it at KubeHunter. This is the dashboard at kubehunter.aquasec.com. You can also download just the Python file at GitHub. So you can find us on GitHub, Aqua Security. We have it's mostly Microscanner, KubeBench, and KubeHunter that are the three kind of the most popular ones. And if you haven't read this, I'd highly recommend it. It's an OReilly ebook that Liz Rice, our evangelist, who's written many of these open source projects. I have a couple copies here. I don't know how we can give them out, but you could download it if you want to save paper. I'd appreciate it. And that's it. Aqua Security. Oh, you guys are still early. The wiki, it's pretty good. It has like just about everything in the cloud native space. You can go on it, and it's really more educational. You don't have to fill out forms to download stuff. Any questions? Not super expertise, but happy to answer questions. You guys have any?
How the rules are
The what?
the rules, for example.
Sorry. The rules for microscanner, for example, how they are maintained.
The configuring the blocks of the builds, for example.
Oh, who maintains them?
Oh, so that's maintained by it's maintained by the NVD score. So that's public knowledge that you'll find that in any database. We're also working with the vendors. We're just compiling data. In our enterprise product, we have a cybersecurity research team that also slightly modifies these scores to make them more specific to what's in the container environment, and reduce false positives too for containers.
Over here.
I suppose it would be great to have all of this that you showed us, but for the beginner, what would you recommend to start with?
That's a good question. I think it begins with scanning. Are you managing a Kubernetes cluster too already? Okay. I mean, sometimes it's helpful to use some of the installers out there to start to have some of these configurations. But I would say Kubench will give you a lot of information and feedback how you can fix quickly. And honestly, the Kubernetes ebook, it's pretty easy to read, and you'll be able to solve and knock off most of the simple configurations that you need to build a stronger security posture. But it really begins just doing things earlier and having that mindset early on in the process, rather than waiting later when you're about to roll into production, which is what some organizations do. And yeah.
Any other questions for our first speaker? Okay, all right.
What can you advise to store secrets besides Vault for Kubernetes?
To stop secrets, or how to manage them inside?
To store and to store secrets.
Outside of the Kubernetes cluster?
Yes.
We see a lot of people doing HashiCorp Vault. It's also
something else besides Vault, in a cryptographic way to store secrets. Do you have any advice for it? Yeah.
Not personally. Sorry.
I have a lot of problems with Vault, and we are looking for another solution.
You will. Are you talking about delivering secrets to containers?
Yeah.
Yeah. We do that with our product. We could take that offline, but we were able to, we deliver assure the secret is being delivered in a TLS method into the container, rather than being stored in the Kubernetes cluster.
Okay. So I guess you are using Vault, yeah?
Well, Aqua isn't a vault. Like I said, we mount as a sidecar container on the Docker socket, so we're able to actually make changes inside the containers and enforce the commands that are run. And so secrets injection is one of the things that some clients look for. Yeah.